it's time to get this party started. Welcome to a tour of Azure Databricks, and good afternoon or good morning or good night, depending on where you are in the world. I am Jonathan Wood, a software consultant here at Wintellect, and if ever you need to reach out to me, ask a question or anything, just feel free to reach out to me on Twitter at jwood. So let's see. So if you haven't heard of Wintellect before, we are a consulting and training company. And for our training, we have the traditional instructor-led training in classrooms, but we also have an on-demand video training with our Wintellect Now offering. But we've also put our knowledge into books, in fact, over 30 of them. And if you've heard of Jeffrey Ritter, you probably know him. He has a famous book here, CLR via C#. And we have some consultants of ours have also written some books too. And a couple of highlights about our accomplishments. We are a Microsoft Gold platform and Cloud platform, Gold and DevOps and Data platform as well. All right, so what we're going to cover today is what exactly is Databricks and kind of what the problems that they try to solve for you. We'll take a little bit of a step back because Databricks uses Spark as a backend, and we'll kind of go into just a few things and why you would want to use Spark in the first place. And then we'll touch on why you would want to use Azure Databricks instead of the standalone Databricks product. And then we'll get a little deep dive into the different components of Databricks, the clusters and notebooks and some of the jobs. And then we'll touch on a couple of demos showing, how to use Databricks and a couple of scenarios in which you would use Databricks for. And then at the end, we'll do a Q&A session. But before we get started, quick question for all of y'all. And let's see, bring up the poll. Have y'all ever messed or heard of Databricks before? Oh, there we go. Okay, so most of y'all probably at least heard of it anyway, so that's really cool. Hopefully I'll show y'all a couple of cool things about it. So first of all, what exactly is Databricks? Well, officially they say it's an easy to use, collaborative Apache Spark-based analytics platform. And with that, I want to highlight two things here, the easy to use part and the collaborative part. And hopefully you get to see just how true those are on how easy it is to use. Basically, just kind of a one-click setup, pretty much. And then the collaborative part, where you can collaborate with all the members of your team on your notebooks. And speaking of collaboration, let me kind of give you a scenario here and why that's kind of important and why it's a big thing that Databricks tries to bring to you. So you say you have kind of a team, or maybe not even a team, just different people on different teams working on the same project. First, you have the data engineer who is responsible for kind of ingesting all the data and then maybe transforming it and then loading it to kind of a single space. And with that, they come into that can be ingesting it from one source, or most likely ingesting the data from a lot of different sources. And that data can be in, all sorts of different, all sorts of different flavors. You have CSVs, maybe from some databases, and they all have to come together into one single source. And from that source, you have your data scientist who takes that data, and then they analyze on it, do some exploratory data analysis, and they may even make some machine learning models based on that data. And then you have your business analyst, and this is a person who really knows the business and the kind of the different domains in which all that data is coming from and what all the columns in the data means. And they're kind of responsible to review the data and help make decisions on how best to use that data. And so you have that happen, and kind of what probably happens a lot is your data engineer brings in the data, your data scientist does their analysis on it, and do their models. But then when the data scientist presents on that what they found on their analysis, sometimes the business analyst may come in and say, well, what about this one place with this important data that hardly anybody knows about that's going to be important to this analysis? And the data scientist is going to go, I have no idea about that data. So if they were able to collaborate on it as the data scientist was doing their analysis, and even when the data engineer was loading in their data, they could have saved a bunch of time doing all of that. So the data scientist wouldn't have to go back to the data engineer and then say, hey, what about this data? And the data engineer is going to be, I had no idea about the data. And so it's going to save a lot of time and effort if they collaborated up front. All right, so a little bit more about Databricks. Again, it brings teams together in kind of an interactive workspace where they can all work from and collaborate on. And I mentioned that one-click setup where you have fully managed environments, so you don't have to worry about any of the infrastructure, handling the servers, or installing Spark or anything about that. And you can integrate with kind of a wide variety of data stores and services. And you can even add some AI capabilities, such as the ML lib that comes with Spark. And speaking of Spark here, we're going to touch up a bit on that. Databricks is built around Spark. In fact, some of the big contributors of Spark created Databricks, so they definitely know their Spark. And Spark is optimized for performance, and it has supports for Python, R, Scala, and it has those machine learning APIs that I mentioned too. A little bit more about why you would want to use Spark. The main thing is it has an in-memory engine. And if you're familiar with Hadoop MapReduce, Spark is it can be up to 100 times faster than Hadoop MapReduce because Hadoop MapReduce is more file-based, whereas Spark is in-memory based. And in Spark, you have the data frame APIs, which those in itself are optimized for performance. And hopefully they will see in the demos that they are easy to use for analysis. And if you've used pandas at all, you're probably going to be pretty familiar with how to use this data frame APIs. It's a little bit different, but the ideas are kind of the same. And again, that machine learning library with ML lib, and then you have the streaming APIs that come with Spark as well. And those two things can be scaled up depending on your data. And a couple of reasons why you want to use Databricks on the Microsoft Azure platform is that you have a bunch of different integrations with a bunch of Azure services. You can integrate into Power BI, and what we'll see in the demos where you can integrate from Azure Storage to bring in your data to read from, and we'll also show how you can store that data back into Azure SQL. And then you have your security that comes with Azure. You have your Active Directory, so you have single sign-ons for everybody. And you have your data compliance, so all your data within Azure can be HIPAA compliant. And I believe that any data transforms within, any data movement within Azure is compliant as well. And then it wouldn't be Azure if it didn't have the auto scaling. And so depending on your data load, it's going to scale, and that'll also help you reduce costs. So it'll scale down if you don't need to use a bunch of compute power. All right, so now let's get into kind of the nitty-gritty here of Databricks. And the first thing you have here are the clusters, which are going to be kind of the heart of Databricks. And this is where Spark is going to run within Databricks. And this is where that easy setup, one-click setup comes into play here. And here you can tell it to auto scale based on the load, where you can set the minimum and maximum workers and enable auto scaling. And you also have an option to terminate after a set time of inactivity. Now, this isn't going to delete your cluster or anything. It's just going to shut the cluster down. And this is great for that reduced cost thing, because you don't want a cluster running idle when it doesn't need to, and that's going to take up kind of some compute, which is going to make some charges on your account. And then you have the notebooks, and if the clusters are the heart of Databricks, then the notebooks are going to be the muscle of it, because this is pretty much where everything is, where you're going to interact with Databricks and run all your code. And you can have notebooks that can be within Python, R, Scala, or even SQL for code. And you can have Markdown for text too, so you can write descriptions of your code and document as you go. And a couple of advanced notebook features that I think are actually pretty nice. And we'll see the widgets and the demos. And what these are is where you can kind of have some HTML elements within your notebooks, such as drop downs, text, multi-selects, and it just kind of helps you parameterize your notebooks, so you don't need to hard code all your values. Then you have these workflows where you can run multiple notebooks in kind of a pipeline, and these can also be used to pass parameters. And so the main reason for this is that instead of just having like a one big, huge, long notebook that does all of your data ingesting, your transformations, loading, then your data analysis, and creating your machine learning models, and that can be a pretty big notebook if it includes all of that. But what you can do is you can separate those out to different notebooks, and you can have your ingesting the notebook be your first one, and then after that you can automatically run all the subsequent notebooks after that. Then you have these jobs, and it's pretty much where you just run notebooks on a schedule. And with these jobs, you can set alerts for them if they fail or timeout, so they can email you. And you can set a number of retries if it does fail. And kind of the big thing with the jobs is you can tell it to use an existing cluster. And the thing with that is that the existing cluster does need to be running. But instead, I would recommend to just create a new cluster when you run a job. What this is going to do is, once again, it's going to reduce those costs, because you don't need to be reliant on an existing cluster to be running idle. So you don't need to, again, waste any compute time where you don't need to. All right, that was pretty quick there, and so we'll go into our first demo. We'll kind of show how to create an instance of Azure Databricks within the Azure portal. Then I'll show how to load some data within Databricks and go over creating a cluster. And then I'll go through a notebook where we take the data that we will load into it and do a couple of analysis on it. So I'm gonna go to my Azure portal here. If it lets me log on, of course. There we go. So to create an instance here, we'll go to create a resource. And you can search for Azure Databricks up here, but you can also go to Analytics and Azure Databricks. The main thing you have to do is just create a workspace name. So give it kind of a unique name here, and a resource group, and a pricing tier. And oh, it looks like they added a trial actually, so that's good. So if you want to play with it, go ahead and use the trial. But you also have the standard and premium, and the big difference here between these two is that premium will allow you to have these role-based access controls, while standard just uses the main sign-on Azure AD security for it. So you set that, and you would just click create, and that does take a few minutes to do it. And like a cooking show, I already have an instance in the oven. And once you have it, you have this overview pane here. And there's not too much you can do within Azure and Azure Databricks. And so you just click Launch Workspace. And if you can see here, there we go. And you see here that it's using that Azure Active Directory sign-on. And here is kind of the basic interface within Databricks. So the first thing, like I mentioned, the cluster is the heart of Databricks. So we need to create a cluster to actually do anything. So go to the clusters and go to create cluster. And this is where that one-click setup comes into place. All I need to do is give it a cluster name, and I can just click create cluster, and that's the least amount of work I have to do. You can have a few options here. You tell what kind of Databricks runtime has here. So whenever they make updates to Databricks itself, they have a new runtime. And with that, they'll update Apache Spark and Scala, and they'll update Python in it as well too. Speaking of Python, you can tell what version to use. And I kind of wish they would just default to version 3. And I would recommend choosing version 3, because if y'all haven't heard or even used Python at all, but it is said that version 2 is just going to be fully not supported in a year and a half. So January 1st, 2020, they're going to completely stop supporting version 2. So I will go ahead and definitely start using version 3, especially since a lot of the big libraries now are already starting to stop supporting version 2. So the worker type and driver type, this is kind of how much power you want to give Databricks, and the amount of memory and then cores and all that. These DBUs is the Databricks units, and this, the more DBUs you use, the more you pretty much pay. You can specify the number of minimum and maximum workers, and this is where you have that auto scaling here, where you can enable it or not. So it'll, when it scales down, it'll go down to 2 workers, and it'll go up to a maximum of 8. And this is also where that auto termination is here. And I would definitely recommend to check this, because you want it to auto terminate after when you're done with your cluster. But creating a cluster takes a little while too. So you probably noticed I already have one running here. And to load in some data, you go into the left side here where the data is. And you need to tell it what cluster you want to. It needs to be attached to a cluster. So go to add data, and you can upload your different files. So I'm going to upload. Let's see, where is this thing? This bank CSV file. And we'll take a look at this real quick. And it's not a true CSV file, because as you can see, it's semicolon delimited, not comma delimited, but that's okay. Databricks can definitely handle this, as we'll see in a bit. And so this is just kind of some sample bank data on customers, and it tells them if they've defaulted on their loans or not. So we have that. We'll just open that, it uploads. There you go, and we'll tell it to create a table with the UI. And this is where we tell it what cluster we want to attach that to. And here's where we can kind of get a preview of the data and give it a couple of extra options before it loads it into our cluster. And as you can tell, I've already had this loaded into my my cluster here, which is good. Early on, it didn't tell you if it did until you click create table, so it's good that they're updating these things. All right, so it determined it's a CSV, but it also determined that what dilemma that it uses. And I can tell the first row is a header, and I can go in manually and change the schema of each of the columns. But something new that they added here is I can tell it to just infer the schema based on the data. So that's a cool thing here. You get a preview of it, make sure everything looks good, and then you just click create table. All right, so now that you have data on it, you've got to do some analysis on it, right? So I have a notebook here, bank analysis, create results, and let's see. I'll show you real quick. You get a few things free in your notebooks when you're running in Databricks here. You see in here, I have a Spark session here that I can use. Let's see, I also have a SQL context if you need to use that, which is a Hive context. And I think, what is it? And also a Spark context if you need it. So we're going to use this Spark session to run some SQL, and you would we're doing some straight SQL here, and on our name here, we just give the same name that we would have gotten it when we uploaded that data in that previous step that we did there. So we loaded our data here, and it's a nice format and all that, but it's not exactly Jupyter when you get, if you use pandas, and it's not very, it could be more visually appealing. But we can print the schema using this print schema and all that. And this is the Spark data frame APIs, by the way. We can check our schema. I changed the schema on the age and the balance, but this was before that infer schemas and all that. So everything else is going to be strings. And then I just did kind of a shape of the data. So we have 4,500 rows and 17 columns. So what I mentioned before about having a better, kind of a more visually appealing output here than what we have there, Databricks has this display function that you can use on your data frame. So that's much better, isn't it? It uses a bit more of the HTML properties here, and this is actually a bit better than what you would get from Pandas and Jupyter Notebook, because up here I can actually automatically sort on columns. But what I think is even better is you come down here and I can chart instantly. In Jupyter Notebook, I would have to write code to do all of this. And I can do different things with this too. So let's see, got different kinds of charts. Let's do a histogram on, let's see, on the age. So you can do real quick exploratory data analysis by looking at the charts, just all kind of built into Databricks there. So you're going to save a lot of time from all that coding you would have to do in just a regular Jupyter Notebook. The Databricks allows you to run different languages within a notebook. You see up here, I'm in a Python notebook, and you can create notebooks with Python, R, Scala, and even SQL. And here, if you're not familiar with notebooks here, this percent symbol, and then kind of a command right after it, that's called a magic command, which it just gives you some extra functionality kind of built within the notebooks than you would get through just regular Python or any other language. In this case, I'm telling it I want to run SQL code right throughout the rest of the cell. And if I run SQL code, it's going to automatically wrap that output into that display function for me. So I don't need to do the extra step here in Python and display that data frame. And I can continue to use the data frame APIs, in this case to do kind of a select on just the age. And I can still use this graphing functionality if I want to. But if you're like me and you're a big fan of pandas, the Spark Data Frame API has this toPandas function, which is really nice. So you can, if you really use pandas to do your analysis, you can do that right here within Databricks. You don't have to go to a Jupyter notebook and do it, and then try to conform all the pandas APIs back into the Spark Data Frame APIs. And you can also, you don't have to, if you'd rather use like Matplotlib or in this case Seaborn to do your plotting, you can do that too and still use this display function within Databricks. You can do a couple of more advanced querying and analysis with the data frame APIs. Here, I'm just checking if there are any missing values, and there are none, which is great. I can do some more advanced analysis. Here, I can use the group by on the job column, and it's wrapped in that display function, so I can still do my sorting. So I can see the management here has the most, is the main job of most of our customers within that CSV file. And I can filter on our data frame. In this case, I'm checking the balance, bring back all the ones that are less than or equal to 0, then I sort on the age. And then I can check this, and I can see, kind of sort by age and do some extra analysis on that. So that's kind of a brief overview of a bit of the UI of Databricks, how to start a cluster, bring in some data, and start doing some analysis on it. And you can do all that pretty quick once you get started. And let's see, the next thing is another demo. And what I'm going to do here is I'm going to use that same bank CSV file. And what I'm going to do is I have this Azure Blob storage container that is housing that bank CSV file. I'm going to read from this within our Databricks notebook and do a couple of transformations on it. And then I'm going to send it right back to Azure into a SQL database. And I'll run this to show you all that this is indeed empty. There's nothing here. And right up here at the top, you probably notice these widgets. So I can use the DB utils, which honestly to me, I always instantly think database utils, but it's Databricks utils. So it's kind of just I'm used to DB being database. So and you have this widgets object, and you can create different widgets from that. And in this case, I have a couple of them here. And this is where I'm going to parameterize my SQL or my storage information so I can get access to it. And here's where kind of the integration comes in from that I can use Databricks to kind of integrate into my Azure Blob account. And what this is doing is just setting my Spark configuration to kind of mount Databricks, or to kind of mount the storage account into Databricks. And again, I'm using another magic command here, and I'm just going to look at all the files within that storage account. And as we saw in the Storage Explorer, we have our bank CSV file. And to kind of show how you can get items from the widget is that that widgets object has a get command on it, so I can get whatever is filled in here. And to read in that CSV file, I'm going to use the Spark APIs to read it in. And also, if this looks weird to you, this slash, that's just telling Python that I want to do a line break. I think on Jupyter notebooks that kind of handles that for you, so you don't need to do that. But in the Databricks notebooks, you do need to do that. So I'm reading the CSV file from the storage account location, and I'm telling it that it has a header and to infer the schema, and I'm letting it know what the limiter that it's using. All right, so we get that same data that we saw earlier. And now let's do some transformations on it. So I'm going to check out the number of columns here in our data set. We see we got 17 number of columns. Well, if you kind of maybe remember from our database here, we don't have, it doesn't look like 17 columns. In fact, we have 8 columns minus the ID column there. So we got to do some transformations to get the number of columns to match. And before I do that, this is kind of if I was working on a team and I had a business analyst on there and I wasn't sure exactly if maybe a campaign should be included or not. Because maybe it feels to me like a data engineer or data scientist, like, should we include this in our analysis? What you can do is you can highlight a certain part of your cell. If you see this little bubble pop up here, you can click on it, and you can create a comment on it. Should we include this in an analysis? And then and your data business analyst can look at it, and they can go into it, and they'll go into it, and they can reply back to it if they need to. So that's kind of a big part of that collaboration. And another one, while I'm on the subject here, if you look up here to the right, see this revision history. Databricks includes kind of a rudimentary version control of the notebooks, so you can go back to a previous one if you want to. But if you look right here and click on that, I can link to a Git repository for it. So I can have I can use Git as my version control for my notebooks, which is a good thing to have. It's always nice to have version control. All right, so off that tangent there, I'm going to drop my columns here. There we go. We got our 8 columns that we need. But another thing to look at, look, our column names here don't exactly match our column names that we have in the database. So we have has defaulted, has housing loan, and what we have here is just default and housing. So we need to rename those columns. With the data frame API, I can just use the with column renamed and rename those. There we go, we got those. And also what you may notice is in those columns that we renamed, the data values are either yeses or nos. And what we need in our database we can't really tell just by looking at the empty ones here, but these are bits, so we need zeros or ones. So we need to kind of change that here. And I'm going to use the with column function here. And when the has defaulted or these other ones equal yes, I'm just going to put a 1. Otherwise, I'm going to put 0. Here we go. That worked. And just to be on the safe side, I'm going to cast all of those from strings to integers. So I'm doing this in a couple, kind of 2 different ways just to show that you could. This first way here with the with column, you can actually chain these all together because they have a bit of a fluent API where you can do that. But in here, I'm just specifying my columns and doing a loop on those. And within the loop, call the with column and then update my data frame within the loop. There you go. We can see that has changed the data type. And now to the load part here. So I got just going to specify some of the database credentials here. And just for the sake of loading time here, I'm going to take the first 100 rows here of the data frame, and that just brings back a list of a row type, I believe, and I'm going to create a new data frame based off that list. And with that new data frame, I'm going to use the Spark APIs to write and kind of use kind of a JDBC with the connection string here to the bank data table, and I'm going to append to it. Otherwise, it'll kind of override on it. And I'm going to just give the username and password as my options. There you go. It didn't take very long. And to do a quick check here, there's all our data loaded into Azure SQL. So that was kind of an extract, transform, load scenario. And now we did that manually, but when I mentioned jobs within the slides there, if you come up to the top, there's a schedule here. And this is where I can schedule this notebook as a job. And I can specify when I want it to run. So maybe every day, I'm on Eastern side, every day at 3 in the morning, I can do that. I click OK, and it'll spin up a job every time it matches that time. But another cool thing you can do just to take this further is if you've heard of Azure Data Factory, you can actually now create kind of a pipeline where it monitors this. You can set up to monitor a blob storage account, and if there is a new file that gets to it, it'll automatically run that pipeline. And within Azure Data Factory, you can run an Azure Databricks notebook within there. So you can kind of pretty much just set all of this to be automated pretty easily, I think. And I think that's, you set it up once and it pretty much is going to run for as long as you need it to. And then going back to the slide here where you did all that work, it's all that is automated. Your data scientist could come in each day, kind of review the data that was automatically loaded, and they can probably automate their process, especially if they have a machine learning model and it kind of trains back on it every day based on the new data. They can automate that too. So you set up all this once and you can have a fully automated system to bring your machine learning models to production. So I think that's a really cool way to use all of these things together. All right, so one quick slide before we end. There's a couple of takeaways. I hope that you take away pretty much from all of this. First thing is the Databricks clusters. I hope that you saw that they are very easy to create, and you can have that one-click setup if you need it. And you don't have to worry about any of the infrastructure. Databricks handles all that for you, and they help you reduce costs from that, just the termination, the automated termination after it's been idle for so long, and with those jobs where you can just create a new cluster, run a job, and then terminate the cluster. Then you have the power of those notebooks, where you have kind of the built-in version control, but you can also link it up to a Git repository. You can make comments on it, so you have that collaboration within the notebooks themselves. So as you're going through the data by itself, you can instantly start collaborating on it. And then to make things a little bit easier, you have your widgets where you can parameterize different parts of your notebook. Then again, you have those jobs where you can easily create schedules of your notebooks. And I mentioned it earlier, but run them on a new cluster, so you don't have to worry about having a cluster already running. And then you can set it up for those alerts in case if it does fail, you can be notified and go in and fix it real quick. And then you have those integrations. You saw how pretty easy it was to integrate the blob storage and the SQL, Azure SQL database there. All right, and with that, I can do some questions. Let me get this. Let's see. Are the notebooks meant to be the final production artifact? Yeah, that's pretty much what's going to be running in production, or what you put in those notebooks. I mean, you can use them for kind of your exploratory data analysis and all that, but usually you would kind of clean those up, and then that's when you would get those scheduled or get them run into Data Factory or something like that. With the slides we sent out, yeah, we will. Actually, I'll go to it. We have a webinars GitHub repository, so we will put the slides there for y'all. There it is. By data stored in the cluster. Cleanup. You mean the data that's like that CSV data that we uploaded to it? If you load in that, so it's pretty much going to keep, as far as I know, it's just going to keep the data that you upload to it. You probably could just use a notebook to kind of clean it up and then put it back into Databricks. Probably also, Databricks does have a CLI that you can use where you can easily upload data to. So I think that's what you mean. All right, I don't see any more, so I guess we will end the webinar. Thanks everybody for coming. I know it's it took